Welcome to clickmyproject.com. This video demonstrates an image processing concept about a content-based scheme for CT lung image retrieval. In this paper, a content-based scheme to retrieve lung computed tomographic images is presented. This paper proposes a method based on DCT or SA-DCT transform domain. As these techniques are old, we introduce a new method based on k-means and hierarchical clustering to retrieve lung CT images. Our method consists of three main modules: the input module, the query module, and the retrieval module. In the input module, based on 6 selected regions of database image, features are extracted and fed into k-means to initialize the clusters. The main steps in k-means algorithm are: firstly, we need to select an initial partition with k clusters. Step 2. Generate a new partition by assigning each pattern to its closest cluster sender. Step 3. Compute new cluster senders. Repeat steps 2 and 3 until cluster membership stabilizes. In query module, from the selected query image, user selects 6 interested regions of square or rectangular shape. The features of the selected regions are extracted using moment invariance. Based on the computed features, similar images are clustered. In the retrieval module, we merge clusters from the same relevance class using a minimum distance criteria. This process is repeated until the number of remaining clusters become relevant to the image categories in the retrieved window, and the system will output a set of candidate images that are similar to the query image. The flow of the project starts with the input module. In the input module, based on 6 selected regions of each database images, features are extracted and fed into k-means to initialize the clusters. Once the clusters are initialized, the features and the cluster IDs are saved in the database. In the query module, from the selected query image, the user selects 6 regions. Features of the selected regions are extracted using moment invariance. In the retrieval module, based on the computed features, similar images are clustered. Once we have determined the cluster similarity matrix, we attempt to merge progressively clusters from the same relevance class using a minimum distance criterion. This process is repeated until the number of remaining clusters become relevant to the image categories in the retrieved window, and the system will output a set of candidate images that are similar to the query image. Now we'll see the demo of this project. Right-click on mainfile.m from the source code folder and select Run File. So the processing of the database images is taking place. That is, each database images is divided into 6 regions and features are extracted from each region and fed into k-means to initialize the clusters. Once it's done, the cluster IDs along with the features are saved into the database. So this is the end of the input module. Now in the query module, I need to select a particular image from the dataset folder, and here I select an image and click the open button. So this is the query image I have selected, and this is the 6 regions I have selected. From this query image, I extract features from these selected 6 regions and compute the minimum distance criterion in order to obtain the matching image result. From this demo, we can conclude that our method automatically retrieves the most matching images to that of the query image using k-means and hierarchical clustering. Thank you.